Alright, so I'm actually back, and previously we did, the introduction. I didn't record the first lecture, but that's okay. I did record the second lecture, but that was in two parts. 30, okay, the strings, input, output, and the branching. And today we are going to proceed with the lecture 3, which is iteration. So I'm just gonna start the lecture. So let me make sure that my recording is going perfect. Yeah. So let's just start with the lecture 3.
So let's start today's lecture. Today we're going to be talking about the idea of iteration, and iteration is another way we're going to add control flow to our programs.
So what do you mean by control flow? What do you mean by control flow in Python program? Okay. Recipe. So they did mention this specific term recipe. That grandmother her grandmother wants to cook cookies. So what she needs is dough. You know, then you have to cut dough in the specific shape and put it in the oven. Then take it out of the oven after, I don't know, 30 minutes. I have no idea about cooking cookies. So, and if it's cooked, we check the condition. If it's light brown, or either it's too brown. So if it's light brown, we are going to put it in the oven for another 10 minutes maybe, and then check if it's dark brown. And if it's dark brown, means it's ready to eat. So that that was one example that she told me.
But before we do that, let's do a little bit of a recap on, let's do a little bit of a
Yeah, so you do need a little bit. I do need a little bit of recap, because I myself don't remember, and I personally wrote almost nothing in my notes, because everything I actually try to remember most of the things right over here. So yeah.
recap of what we've done so far last lecture. Because last lecture we actually introduced a different mechanism for control flow, branching. And the control flow is basically a way for us to tell Python not to go systematically through the code. Branching was a way for us to tell Python, hey, based on some condition being true or false, either evaluate some set of code or another set of code, right? Which was not going linearly. We were actually kind of skipping around through the code. So that's what we learned at the end of the lecture, but we also learned about input and output, so a way for us to write interactive programs.
Wait. Let me just open my VS Code. So that's the lecture 3. So I'm gonna name that main3.py. Yeah. Perfect.
And we learned about a new data type, the string. So the string was a sequence of characters. Hopefully you got a chance to do a little bit of exercises on MITx as practice for today's quiz with strings and branching. Okay, so in branching, what did we learn? We talked about how to actually add a branching point in our program. So we did that using these particular keywords. So when you type them in your program in the file editor, you'll see that they kind of turn a different color. That tells you it's a special word in Python. And these keywords are how we told Python to put a branching point. And the colon kind of ended the branching conditional. And then anything that was indented as part of that conditional was code that would be executed when that condition was true. So I'm just going to quickly go over each one of these boxes. So the first one up here was the simplest way that we could add a conditional to our program. It basically said, hey, go through the program. When you reach this if condition, Python would check the condition and say, if that condition is true, execute the code that's indented as part of that block. If the condition was not true, don't do anything, just carry on with the remaining program. If we wanted to do something else, so if the condition was not true, if we wanted to do something else, we added this else clause here. And the else also has some sort of code indented as part of its code block. And that code would be executed when that condition was false. OK. So that was a really simple if or if-else code structure. But sometimes we want to have code that checks for many conditions, right? Not just one. That's where the elif structure came in. So we would have an if condition that starts our code block. If that condition was true, as usual, we execute the code that's part of that block. Else if, so elif, we could insert another condition. And Python would say, OK, well, if that one wasn't true, let me check if this next one is true. And then we would execute the code that's part of that code block. And we can chain as many of these elifs as we want together. And Python will evaluate the very first one that it finds true that's part of this chain, okay? Even if more than one is true. It is possible none of those conditions were true, in which case Python would basically skip over all of them and do nothing, enter none of those code blocks. If you wanted to have a structure where if none of those conditions were true, you wanted to do something, you could put an else at the end of a whole chain of if, elif, elif, elifs. And the else would be executed when none of those conditions are true. Okay, so hopefully this is just recap. One sort of tricky thing to remember is the if starts a code block. So the if can have an else associated with it, or it can have an elif, 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 and an else associated with it. But if you have if condition and then followed by another if condition, both of those code blocks could potentially be executed because the ifs are independent, right? It's not an else situation. They're just.
All right, so that's one thing that to be noted on, that if you're writing two consecutive if statements, the if conditions, so it's potentially possible that both of the code of block is going to execute because both are independent. So I'm just going to write that.
Another if code block that gets started. So the way we told Python, again, just to reiterate, the way you told Python which code to execute when the condition is true is by indentation. And indentation is something you have to do. It's not optional in Python. OK, so let's take what we've learned so far and code up a really simple game. So this is sort of a very simple variation of the Lost Woods in Zelda, sort of my version of it. Let's say it's kind of a trick level where you have your character and they enter the Lost Woods. They're presented with this screen. And the trick here is you ask the user if they want to go left or right. If they say right, you're basically going to present them with the exact same screen all over again. So it's kind of representing that they're lost in the woods. And as long as they say, I want to keep going right, I want to keep going right, I want to keep going right, they're basically going to see the same screen over and over again. And the trick to getting out of the woods is to say, I want to go left. Okay. So no matter how many times they've said right in a row, as long as they type in left, they're out of the woods. Okay. So let's try to code that up with what we know, just conditionals. We have an if-else, right? The if says if the user exits right, we're going to do something. And otherwise, we're going to say that the user said left or something else or exit, and then we're going to tell them that they've exited successfully. All right, now if they said exit right, what do we do? Well, we're going to show them the exact same thing again. So we're setting the background to the same woods background. And then they're presented with the choice all over again, right? do you want to exit right or you want to exit left? So if they say exit right, we would do something. And otherwise, we would tell them they successfully exited. Okay? Well, what if they exited right? If they exited right, then we would do something again, basically present the
Okay, so here's the thing. I get where is this thing going. So, when the user says that I want to go right, I'm gonna end up in the forest only. But if I exit left, I'm actually going to leave the forest. Or basically exiting the forest. But here's the thing: for every input, we have created that if-else statement, and what if the user trying to input multiple values, or maybe infinite, but not infinite specifically, because that's not possible, but let's say a very big number. Let's say the user tried the user gave 100 inputs, and out of 100 inputs we have 99 uh, you know consecutive 99 right, and the 100th input, the last input is basically left. So are we actually going to write if else statement 100 times? uh, the answer to the question is a simple no, because that would have just take a lot of time to write. Maybe you could have just copy and pasted, but that's not the sufficient way to write the program, and that's my own guess to whatever they're trying to explain. That's my simple guess. So instead of doing that, we are actually going to use loops so that we don't have to write the code again and again.
with the same situation. So we would set the woods background again, and we would ask them if they want to go right or left again. And otherwise, if they said left, they exit. So we already see a problem, right?
So here it says that and so on and on, and so we are not going to write the same block of code again and again, because that's not even sufficient, and maybe that's going to increase the size of the file.
Deep do we make this nested loop situation, right? Here we already have 3 in case the user said I want to go right 3 times in a row. But we don't know how persistent the user will be. So
Yeah.
how do we know when we're writing our code how deep to make this nested loop? We don't, right? We won't be able to really code this up very well with what we know so far. And so that's kind of the motivation for introducing iteration. Because the situation on the previous slide fits really well with some task we want to repeat multiple times, as long as some condition is true. In our case, the condition is the user says, I want to exit right. So while the user keeps saying exit right, show them the woods background and ask them again, which way do you want to go? And so while that's true, just repeat this set of things. Check that they said exit right, show them the woods background, ask them again. Check that they said exit right, show them the background, ask them again. And if at any point they'd say, I don't want to exit right, we break out of this loop, and we kind of rejoin the rest of the program. That's kind of the terminology we used with if statements, right? We set the background to the exit background, and they're out of the woods. So this sets the scene for while loops. Here's another example of while loops sort of in the context of watching a show. So if we want to start a new show on Netflix, and we want to watch all episodes of the show in one shot, we're going to tell Netflix we're starting a new show, and while there are more episodes to watch in this show, we're going to keep watching the next episode, right? So if there are no more episodes to watch, then we're done. Netflix will suggest 3 more shows like this one. And while there are more episodes to watch, so yes, there are more episodes to watch, we're going to play the next episode in sequence. So that's the idea that we're trying to get at with while loops. In Python, this is how we code them. So we start a while loop with the keyword while. So this, again, will turn blue in Python because it's a special word. Some condition is true. Okay, so this is, again, some expression or something that will...
That actually reminds me of, the infinite loop. I do remember this. Like I started this long ago, maybe 3-4 years back. Let's just try that, you know. While true, okay, while true, print yo. Okay, let me, is that going to, yeah, exactly. How am I supposed to stop? Shit. Control C. Okay. All right. All right. I didn't knew how to stop the code. You know, it could have just overloaded my memory. But anyways, now that I have learned, I won't forget. Okay.
Evaluate to a Boolean, like we talked about in last lecture. Okay, colon. And colon tells Python we're starting a code block that's part of the while loop being true. And as usual, the code block means we're going to indent these lines of code, right? So whatever we want to execute.
So the moment we put colons, it actually evaluates to a indentation, and inside the indentation we write our code.
When the condition is true, will be indented. When the indented statements are finished executing.
Wait, what if I just write break and then, okay. So once you write the break, you know, it actually executes this code and break. So when you break the loop, what you did was you came out of the loop. You know, while true, so it's gonna print yo, and then it's gonna execute break. So once it break, it comes out of the loop and it's try to execute the next line. But since there is no code in the next line, it just prints yo. That's it.
Python automatically goes back and rechecks that the condition. So it rechecks whether the condition is true or not. And this is done behind the scenes, right? When you code
Behind the scenes, okay. So it's going to recheck the condition. But because in our infinite loop, the condition is always true, it's gonna print yo for the infinite time.
put up a while loop, when you type in the keyword while, Python will automatically do this behavior. It'll check the condition, it'll execute the lines of code indented, and then it'll go back and check the condition again. If it's still true, it'll execute the lines of code indented again, and then it'll check the condition again. So it's not something you have to code up. You don't have to tell it to go back. As long as you're writing this while loop, Python will automatically do that sequence of steps for you. Okay? So when the condition becomes false, Python will no longer execute the stuff that's indented inside the while loop, and it'll go rejoin the rest of the program at the same indentation level as the while loop. Okay. So notice that the condition is kind of something that's dependent on, the fact that we're doing this code over and over again depends on this condition being true. So if the code inside is not ever changing anything related to our condition, then it's very likely, it's actually for sure, that this loop will execute infinite number of times. So this is kind of the pitfall of while loops. It's possible that if you're not careful, your code will execute an infinite number of times, and it'll just never terminate. And I'll show you how to deal with that in a couple slides. So let's try to code up this Lost Woods program in.
Yeah, so, okay, so I already saw the code, you know. Okay, anyways.
Just with a while loop. So here we've got our question that we ask the user, do you want to go left or right? And we're going to grab the user input as a string and save it in a variable called where. So whatever the user types in, it'll be saved in the variable called where. So in my computer memory, the way this looks like, if the user types in write, that particular sequence of characters, that'll be saved as the variable where.
Where?
So then we finish this first line of the code here, and then we check while the value of where is equivalent to write, what are we going to do? We're going to ask the user again, where do you want to go, left or right? So I'm going to say write again, and then this memory is going to look exactly the same. If the user keeps typing in write, I keep reassigning the variable where to have the value
Right.
R-I-G-H-T.
Yeah.
Okay. At some point, the user might type in left, in which case we're going to lose the binding from a variable where. From the specific sequence of characters R-I-G-H-T, we're going to bind it now to the characters L-E-F-T. So at some point, after repeating this many times, the user...
So this variable where is going to have a value left. There was a term binded to. So the term left, L-E-F-T, would be binded to the variable left. And when the loop checks for the condition where where this particular variable where is equals to right or not, so that would give me a false statement. So it's just gonna end and come out of the loop, and it says print you got out of the lost forest.
will type in left, and we're going to
So yeah, I get what's the significance of the while loop.
have where is equal to left. And at that point, when the condition is being checked again, Python will say, nope, this is not equivalent. So I'm not going to go inside this code block. I'm just going to go down here and print you got out of the lost forest.
Yeah. Yeah.
So in code, the way this looks is, it's this first one here. So you're in the lost forest, go left or right. So if I type in right, it just keeps asking.
All right. So let's just make w is equals to input. Where do you wanna go? Check for no for while w equal right or still in the forest, still in the forest, and w equals input. Wait, I could have just copy and pasted this code. Where do you want to go? Print, whoa, you are out of the forest now. So let's just run this. So I'm going right, still in the forest. Where do you want to go? Let's try with a capital R, still in the forest. Let's just try left. Whoa, you're out of the forest now. Okay, I get it.
Asking me which way to go. And at some point, I can type in left, and I'm out. Okay. So it's pretty cool, right? We just made our own level
it's pretty
in this
cool.
text adventure. Let's have you think about this question.
What is printed when you type right? If you print right, it would just print this specific block of code, which is print you got out. And that would be false. Okay, and that's one of the reason I went with a capital R. where is it? Yeah, there it is. I went for the capital R, and using a OR operator, because so let's say RIGHT, I could use another OR operator, or W equals RIGST. Yeah, so RIGHT, RIGST, RIGST. So to make this program a little bit better, a better code, we might introduce if else statement to check whether the input in itself is correct or not. you know Otherwise we would just have to introduce conditions, more and more conditions. Yeah.
Question. What if the user types in capital RIGHT? What do you think will happen? Are we going to ask the user to go left or right again, or are we going to tell them that they got out of the forest?
They got out of the forest.
Yeah, they got out. Do you want to say why? Yeah, exactly, because it's not lowercase. So remember, when we're doing comparison, so the equal on strings, it has to be the same case, right? It's case sensitive. And so capital RIGHT, or even some combination like just capital R, lowercase RIGHT, is also going to give us that we got out. So this is counterintuitive, right, to what we...
Counterintuitive. I heard that word in the second lecture for the very first time in my life, and the meaning to counterintuitive is something which is contradictory to the logic. I've just written it in my notes so I could get better at speaking English. Hell yeah.
see as humans, because we see, RIGHT no matter what.
Got out of the forest. Lol.
To mean right. So a workaround for this would be to use sort of a command on the string to maybe convert everything to lowercase, just so it's more easily compared or something like that. Okay, so another use of while loops is with numbers. Okay, let's look at this example. I'm going to ask the user for an integer.
So let me just understand this before the lecturer says. So here n is an input, which is an integer, and we're gonna take it from the user. While n is greater than 0, print x. So it's just gonna print x. So let's say n equals 1 and n is greater than 0. Okay, so and then the near value of the near value, where's my this? Okay, wait. So the near value of n will become n minus 1. So what was the previous value for n? And that was 1. So 1 minus 1. And okay, so as far as I'm able to relate in my mind that whatever the value for would be n, so let's say I took n equals 5, it's gonna print out x 5 times in a row. So let's just try. X equals integer, which is going to be our input. Enter something, well, not something, and while x is greater than 0, print whoa. And then the new value of x becomes x minus 1. I'm gonna save this. I'm gonna run this. Let me just clear this up. Let me just run this. Enter something. So 5. Whoa. Oh, my bad. My bad, my bad. CLS, save into something, so 10. Okay. All right.
And then I'm going to do something really simple. I'm going to print x to the screen however many times the user told me. So if the user gives me 4, I'm going to print.
So that's what I've just explained. Okay, so I was right. Does that mean I'm more intelligent than MIT students? Huh?
Print x 4 times to the screen. So what is this code doing in memory? Well, the user gives me, let's say, 4. What happens step by step? First, we see our while loop. So I'm going to check whether 4, the current value of n, is greater than 0. Yes, that's true.
True.
I'm going to print x to the screen. And then I'm going to do the next line of code that's part of this indented block, which is to take n and assign it to whatever n is minus 1. So I'm going to lose the binding from the 4, and I'm going to take 4 minus 1 to be 3, create a new object, and bind n to the 3. Okay? Next, Python, again, it's part of a while loop, so automatically it looks at the condition again and says, well, now the value of n is still greater than 0. Yeah, 3 is still greater than 0. So again, we're going to lose the binding. Sorry, we're printing x to the screen first. And then we lose the binding from the current value of n, 3, to 2. Okay? So we're decrementing n by 1 each time through this while loop. Okay? Then, again, Python checks the condition. It says 2 is still greater than 0. So again, we print another x to the screen. And then we decrement n by 1. So we're binding n to 1. Again, Python checks the condition. Is 1 still greater than 0? Yes. So we print another x to the screen. So we've printed 4 x's now to the screen. And then Python says, now I'm going to make n to be 0. And then at this point...
Wait. So mathematically, if you think, if I have to say this mathematically, the program will print x whatever the value of n is, n which is the input. But what if instead of decreasing the n never got decreased, and instead it's actually increasing? Oh, so if n never got lower than 0 or less than 0, mathematically the program might run for the infinite time. Let's just try that. So for that, I'm just going to write x equals x plus 1. So theoretically, in my opinion, this program should never stop running. Oh, wait. Wait, what's happening? Enter something, so let's say 1. C. So eventually the x is whatever the value you give for x, it's eventually gonna increase. But initially, if you try to give the value for x less than 0, it's not gonna give you an output, because initially the statement got false, and it's not gonna execute the code, whatever the code is inside the indentation. So let's just try that. Into something, if I put -1, I get nothing, because the code inside the indentation never got executed.
Python will do another check. It's going to say, is 0 greater than 0?
Well, that was interesting.
Oh, and that's...
I mean, it's hilarious that you can do so much with Python, and I'm on lecture 3, by the way, so amazing.
It's going to be false. So it's not going to execute the code block anymore, and the program will be done, right? There's no sort of code to rejoin anymore. There's just the end of the program. So we would have printed 4 x's to the screen. And this is in the Python file I gave you. You can feel free to run it to double check. My question is, what happens, and this is a really common mistake, what happens if we forget this last line?
Well, it's gonna
We can try
print.
it. I can try it
It's
in
gonna print
here.
x for the infinite time.
Yeah, exactly. It's going to go on forever. I'll show you what that looks like.
Ooh, the timing was really good. The time, the timing was really good, huh?
So this is the code when we just have it working as usual. So if I type in 3, it prints 3 of those x's. But if I happen to forget to write this last line, I'm just going to comment it out. And if I run the program, I can enter any number, and it'll just keep printing stuff to the console. Right? So this is what it's just printing a whole bunch of stuff. So you can see this is all.
Wait. So, oops,
Oh,
5.
all the stuff it printed. So yeah, we don't have a program that terminates because the condition here is never actually being, the variable that's part of this condition is never actually being changed inside my loop, right? And so that's a big problem. When that happens, what we can do, and what I just did here is you can click the shell and hit Control-C or Command-C on a Mac, and that will just end the program manually. Or you can just click the red X in the corner. So here's another example of it going infinite, and there's this little red box in the corner. You can click that, or you can click the 3 lines, say interrupt kernel. All that will stop the program. So in this class, we're not actually going to write programs that take seconds to run. So if you find yourself waiting for your program for more than 1 or 2 seconds, then likely you've entered an infinite loop. So you'll want to stop it and try to see where your program went wrong. Okay, so give this a try if you want.
No.
Just so you get the hang of stopping an infinite program, because you'll very likely write a program
Well, I already did it, so I'm not gonna try it again.
that doesn't terminate. So while true, what's the condition here? It's just
So, like, here's the thing, there's one thing that I had in my mind, so, they have this book. I don't know if I spell this correctly or not. John Gottag, I don't know, Introduction to Computation and Programming Using Python, 3rd edition. I have the PDF of the book, so proceeding to this lecture, once I'm done with the lecture, I'm actually gonna solve that book, and so here's the reading part. I was supposed to read the chapter 1 and chapter 2.2.1 to 2.2 after after attending this lecture, but I didn't, so I'm gonna do that. I'm not gonna hold with the problem solving. I'm gonna do the problem solving part once I'm done with the lecture 3. And let's see for the lecture 3, so till 2.8. Yeah.
true, right? So there's no condition that's being checked. This program will run always an infinite times no matter what. Okay. So that's just this little, you try it down here on line 44. Just run it. As soon as you run it, it's just going to print that to the
No.
screen over and over again. Be sure to click the shell to put the focus on there and hit Control-C or hit the red X. All right. So the big idea with while loops is that they can repeat the code inside them indefinitely. So we have to be a little bit careful with what our conditions are and whether we're actually making progress towards having that condition become false at some point. And when that happens, when they run indefinitely, you'll have to manually intervene to close the program. Okay, so now that we've seen a loop with a little bit of
So expand this code to show a sad face and when the user entered while loop more than 2 times. Okay.
numerical computation inside it. So we were changing the value of n inside our loop. Let's have you work.
Okay, okay, so that's a problem. Oh, you try it. All right. Um, okay. So we might introduce an another, we might have to introduce another variable. So let me just get back to my VS Code and uh, let me see if I can get my code back. Oh, there we are. So um, what I'm gonna do, still in the forest, what I'm gonna do is I'm gonna introduce a variable, not x, let's say a equals 0, and while, do we have to use for loop while a while a equals to print, no, is greater than or equal to 2, I have to print the sad face. So how do you print the sad face? Um, you take colon and yeah, that's the sad face. Let me just think how. So let's say if I put, no, wait, and then a equals a plus 1. So initially the value for a is 0. Let me just take a screenshot and put it here. So here's what happening, so you came, you're over here, let's say you're in the line 5 of this code, and no, wait, I think I'm doing something wrong over here. This code, this code and this code is not going to execute because the value of a initially is 0. um, can I put it inside the code? Let's see. What if I just remove this line? Is it going to run? So let's say we have removed this line, and let's say I have, my input is right. So I'm gonna come inside this code, and we're gonna be still in the forest, and it's gonna check. It's gonna check for the value of, no, wait, let me think. We do need to define, or maybe not. I'm confused. So like here's the thing. Okay, wait. So a equals 0. Just gonna delete the older one. So we came inside this loop, and then it's gonna print still in the forest, and then it's gonna get to the while loop. So a equals 2. So that condition No, that condition is not going to get satisfied because let's just try the code. Where we're going to write. I see. So we do need to define a okay, but how we are going to define a function, while function for it? So let's say a equals 0. Can we define an function over here? So let's say while a is less than equal to 0 and a wait, so yeah, okay, I get it. A equals a plus 1. No, wait, we have to define a equals 0 out of the loop. I get it. So a equals 0. Yeah, 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 yeah. This should work. This should work. Wait, it says that something's wrong. I don't know why, but okay, I get it. Need to remove this. So I'm gonna tell you why this might work. Here's the thing. So initially I have the value for a equals 0, and I have defined a uh, variable, and the 0 is actually, what was that term? Um, bind it, the 0 is binded to a, then our program executes the third line and it goes inside the third line. So let's say my input was right, and it's gonna print still on the forest, while a greater than or equal to 2. My bad. So it's supposed to be 2. I'm actually reviewing my code with before running it. Let me just write that 2 once more. So if while a greater than or equal to 2, it's gonna print a sad face, but since my a is actually equal to 0, and then my new value for a will become a, the older a plus 1, which was nothing but 0 plus 1. So I could have just write a new equals old a old plus 1, and that is just 0. So a new eventually becomes 1, and it's just gonna ask the user for the input once more again. Then if I just put it to be right once more again, uh, this condition will not get satisfied once more. So this block of code is not going to run, because now the value for a new is 1. So it's going to evaluate the value for a once more. So a new becomes a old plus 1. Now this time the a old is actually 1, so a new, a n, I'm just going to write it as a n, actually becomes 2. Now the next time when this loop runs, you know my my condition, my loop, the inner loop will satisfy the condition that a is greater than or equal to 2, because since a equals 2, that's going to satisfy the condition, and it's going to print me a sad face. So what was the question? Let's just get back to the more than 2 times. Okay, so if it's more than 2 times, we just have to remove the equality sign. Okay, so if you remove the sorry, my bad, not the equality sign. Yeah, we have to remove the equality sign. So Next time when the program is going to run, the a new will become a old plus 1. Now the a older value will have a value of 2, so it becomes 3. But since 3 is greater than 2, it's eventually gonna give me an output for this. So yeah, I just solved the problem. It was amazing. So let's just try. Save. Where do I wanna? I wanna go right. Wait, let me just add another or operator or w equals. I'm not gonna write CLS. So R. Wait, what just happened? Where do you wanna go? I wanna go right. Still in the forest. Where do you wanna go? Right. Where do you wanna go? Oh, oh wait. Wait, what just happened? No. Okay, wait. I need to break this. I need to break because. Okay, wait. Right, right. I again went right. Okay, I think I need a equality sign over here. So right, right. Still in the forest. So every time I give the program the input as right, it's going to give me an sad face. Hell
Work on
yeah.
this little program. It's an extension of the Lost Woods.
That was definitely fun, solving solving this problem in my own way was, it was just fun.
This is exactly the same program that I just ran a few slides ago, but what I want you to add is an extra printout. So when the user says right more than 2 times, the next time you ask them whether they go left or right, I'd like you to print a sad face right before you ask them that question. It can be on a different line. It doesn't have to be on the same line.
Honestly speaking, I learned Python, 3 to 4 years ago, but I never thought that Python could be this amazing. And like, this is probably for the very first time in my life that I'm actually enjoying learning about Python.
And the way to do that is to try to create a new variable that's going to be
Ooh.
like your counter that keeps track
Ooh.
of how many times how many times this while loop has repeated. So I'll give you a couple moments to do that, and then we'll write it together. As usual, the you try it is in here, so you can just uncomment the code. In Spider, it's Control-1 or Command-1 to batch uncomment, and then you can work off of this code to try to improve it. Okay, so does anyone have a start for me? How can we do this? You don't have to give it to me in full.
Well, I already did. Does that mean I'm more intelligent than an MIT professor? Well, really no, but
We can work our way up to the final program, but what's kind of your first thought here?
okay, all right.
Yes, right.
Create a variable like n or something,
Mm-hmm.
implemented every time the while loop goes through.
Okay, so we can create a variable n at the beginning of our program. What do you want to make it?
0.
0. Okay, good.
0.
0 will keep track, or n will keep track of how many times we've gone
Wait, do you say it's 0? 0.
through the loop. So inside our program, when do we want to change n? Sorry. Every time we go through the loop, right? So every time we want to go through the loop, we want to change n to be a new
So I'm just gonna put this on 2x.
value. So maybe we want to increase it by 1. So n is equal to n plus 1. So now this will keep track of how many times we've gone through the loop. And we can actually double check this by printing n, right? So if we run it and we say right, we've gone once, right, we've got twice, right, we've got 3 times, right? So this means we're incrementing it correctly. Now what can I do with this variable n, now that I have it and I know it's incrementing correctly? Yeah. Yep, we can set up an if statement. So we can check if that value of n is greater than 2, right, according to the specification here. What do you want to do when if it's greater than 2? Print something, right? So we can print the sad face. And let's try to run it now. So if we immediately hit left, right, it still works. If we go right one time, nothing, right another time, nothing, right a last time, sad. And from now on, it's going to keep showing me the sad face.
Alright, so we could have used if statement. I had this thing in my mind initially, but I don't know why I went with a while loop. I don't know. So, you know, with respect to this particular problem, there can exist many solutions. The lecturer used if statement, the conditional statement, and I used a while. Okay, okay. Well, there's nothing wrong in that, honestly.
Questions about this code? Yeah.
Is it possible to test for something that's non-equivalent? Like, is there a sign that's different than the two equals for not equivalent?
Can we check for not equivalency here?
Yeah.
So this particular check checks for what the user typed in. It's possible we can add this if statement that checks for the n in here and something else, but then we would have to have maybe another. I'd have to think about it. But it might be possible to try to combine them inside the while loop.
But there's a symbol that allows you to do that.
Oh, to do not equals. That would be the not equal sign. Yeah. So another thing we can do with while loops is to iterate through numbers in a sequence. If we do this, there's a really common pattern, which actually leads us to the next kind of loop we're going to see on the next slide. But the pattern, when you want to iterate through numbers in a sequence, is you first set a loop variable before the while loop. Inside the condition for the loop, you do some sort of check with that variable. So n was my loop variable outside the loop, and then I test it inside the while loop. So n is less than 5. And then within the while loop, you can do whatever commands you want to do with that n, but then you have to remember to change it in some way. Because if you don't change it in some way, this while loop condition will always be true. So here I'm incrementing n by 1 because it starts from 0. I want n to get to something, right, something above 5, which will lead to my condition becoming false. Okay. So this pattern is actually exists in a bunch of different programs. So here's a program that calculates factorial for me. And here I'm calculating 4 factorial. I'm not excited about the number 4. That's 4 factorial. How do we do this?
All right, so to find 4 factorial. I is a loop variable. So I starts with 1, while I is less than equals x, which is the input, or okay, or like so for whatever value we need to find the factorial. Wait, what does this operator does? What does OBRE operator doesn't? Argumented assignment operator. Oh, Oh, I see. I see. So it just means, wait. So the star equals operator just means, let's say we have x equals x times x, I think. No, it means the another variable, my bad. I'm getting the logic wrong. Like whatever the variable fact. No, wait. I'm just getting this wrong. Wait. Let me just understand this once more. So factorial equals 1 while x is less than equals while I is less than equal factorial. So okay, so we just introduced another variable over here, and then I equals I plus 1. Now the I over here becomes 2. Then it's gonna get out of the loop 2. So yeah, 2 is still less than equal to. Okay, all right. So like here's what they are doing. So they have introduced some sort of variables, and let's say I equals initially the value for I, or for any, the loop variable is 1, and let's say we have over we need to find the factorial for the 5. Okay, so what they're doing is, let me just see the code once more. wait, wait, what? I don't get this. Wait, how does this code, like how does this operator work? I don't get this. So the factorial equals factorial times 2 time. Okay, okay. So let's say there is another variable that equals the I, which is 1. 1 times factorial. Okay, then you increase the value for from 1 equals 2, and when the loop gets overrun again, the factorial becomes I, which was 2 times the 2 2 times the factorial. Now you again increase the value for I, and it becomes 3. So the factorial becomes, wait, have we defined factorial? Okay, so the f is 1 initially. Okay, it becomes 3 times the factorial, the older factorial. And what was the value for the older factorial? That was 2. you know my bad, mathematically that would haven't make any sense. So 2 times f. So just remember, initially here, we are defining this variable f equals 1. So the value for f, that is just 1. And then again my loop runs, check whether if the the loop variable I is less than equals x, which was our, the input. In our case it's 5. So it just runs the loop one more again, and f becomes I. Now the value for I, that equals 4 times f. Now in our case, the older value of f would be 3 into 2 into 1. I've just replaced f with 1. Now the loop runs once more again, and the new value of f becomes the I, which is 5, times the older value of f. So whatever the older value of f was, that was 5 into 3 into 2 into 1. And mathematically, that's the, you know, uh, what do you say, like the not the formula, but that's the mathematical expression for the 5 factorial. Okay, now it goes to the condition once more again, since the value for I, which was our, the loop variable that actually becomes equals to the input, our condition becomes false. So it just gets out of the loop and print. Okay, now we have the value for f is the factorial. So there's one more thing to notice, that they're actually using um, f strings. Yeah, I studied about this in the second lecture. I just remember that they're using f strings, and that's a very smart thing, you know. Okay, I get it. I get it. It's fundamentally very important to understand the core, or the core logic for the code. That's one of the reasons I'm using this blackboard, to understand what my code is actually trying to say. Okay. I'll be just back in a minute. All right, I'm back. Let me just drink some water. Okay, so I understood the code.
Well, there's a lot of things I'm initializing here, but sort of the more you work with loops, you'll kind of get used to seeing, right, what is the loop variable. So I is actually going to be my loop variable. Here it's being set to some value initially outside the loop. Inside the conditional, I'm doing some sort of condition check with it. And then inside the body of that conditional, I'm changing it in some way that gives me some sort of that takes me to the end of my conditional here. So I'm setting I to 0. I'm incrementing I by 1 each time through the loop.
Let's just try this code over here. Wait, how do you comment out? how to use comment out code in VS Code with keyboard. Control, okay. Oh, all right. Now I don't have to create another file. Let me just close this. So we need to define some variables. So x equals 1 and the I, which is the loop variable, that equals 1, and factorial, that is even 1. So while, no, let's say we need the factorial for 5. So while I is less than equals x, f can be written as f times I, and then we increase the value for I, so I equals I plus 1. Okay, so like here's one more thing. Where's the, so this specific operator means nothing but this. Okay, if I'm not wrong from what the Gemini said, and then what we are supposed to do. Yep, print f is the factorial of, let's say, x. So x equals integer, which is our inputs, enter a number. Wait, I just have this doubt in my mind. I don't know why. Okay, okay. Is only, so the factorial function is only defined for non-zero integer values. Mathematicians found a way to connect the dot between those integers so that the concept worked for the decimals and even complex numbers. So they're saying that the extended version of the factorial is also called the gamma function. I've heard about it, with the Greek letter. I don't know what that is. So for any positive integer, recursive function by factorials that only handle integers. If you give it a fraction, it would be an infinite loop or recursion error. However, in the Python's math library, the gamma function built in. Okay, I see. Okay, so I had this doubt in my mind that whether the factorial function can take input for non-integer values, for the fraction values. So it can, but there's an extended version to it which is known as gamma function. Okay, we'll try that. We'll try that once we get into the library part. We are not. Let's see. Let's see when we are going to library, mutability, dictionary. Okay, I don't see, but okay, we will try. We'll try it. Let's get back to. Let's run this program. Enter a number, so let's say 5. 120 is the factorial of 5. So let's say 3. Okay.
loop, and I'm making forward progress towards making I greater than x. Okay? At which point my conditional will become false. The rest of the code, x is equal to 4, just sets the thing I want to get the factorial of. And this.
So here's the thing. What if you put the value of the loop variable to be negative to a negative integer? So is it going to give me a negative output? Let's see, because we are actually multiplying the factorial variable with the variable which is a negative. So okay, let's just try. I'm gonna try this. Enter a number. So let's go for 3. The 0 is the factorial of 3. Wait, what just happened? What just happened? Wait, what just happened? I'm confused. What I just did. So the I was negative of 1. So negative of 1 is less than equals to the input, which is 3. That's correct. So f becomes f times minus 1. So okay, now in the memory the f will have a value of negative of 1, and I, the new I, will become 0. It gets out of the loop, and the the I, which is 0, is still less than equals 3. So f becomes 0. I see. But since the I is 0, I becomes 1. But since the older value of f is 0, multiplying any number with 0 will eventually give me 0. Okay. So that's the reason I got a 0.
Factorial variable is.
Here's the thing. I'm not just watching the lecture and trying to learn the Python. I'm actually trying to learn what Python is trying to do. You know, the pillars, knowing the basics is very important. Yeah.
Kind of my running product. So it's the thing that I'm going to keep multiplying to figure out what the factorial is. So here I'm initializing it to 1, and inside the loop I'm multiplying it by my loop variable every time. So I'm not going to do like a memory diagram for this example, but I will do the Python tutor. And I'm going to step through to show you exactly what this is doing. So x is 4, I is 1 originally, and factorial is 1. Right? So x is the thing I want to get the factorial of. I is going to be my loop variable, and a factorial is my running product. So next step, I1 is less than or equal to 4, so I'm going to enter the loop. Python will calculate the factorial as whatever it is right now multiplied by 1, I. So it's still 1. And then I'm going to increment I to whatever it is, from whatever it is now to 1. So I just want to mention this I plus equals 1 is equivalent to saying I equals I plus 1. And this is true no matter what variable you have here. Basically, if you have, fact times equals, 2 or something like that, that basically means factorial equals fact times 2, right? So that's kind of the pattern here. These are equivalent, and these are equivalent. This is just shorthand notation in programming. So that's what this line here means. I plus equals 1 means I equals I plus 1. So at this line here, I'm taking whatever I is and adding 1 to it, 2. And then I do the check again. And remember, Python does this automatically, right? Because we're using a while loop, it goes back to the condition and checks it again using these new values for the variables. 2 is still less than or equal to 4. Yeah. So again, we go inside the loop body. Factorial is whatever it is right now, 1, multiplied by I, 2. I is going to be 2 plus 1, 3. And then again, I'm checking that 3 is less than or equal to 4. It still is. So then we're going to do factorial is whatever it is now, 2, multiplied by whatever I is, 3. So now it's 6. I is going to be 1 more than what it is right now, 4. 4 is still less than or equal to 4. We're going to go inside the body. Factorial is whatever it is right now, 6 multiplied by 4, and then 24. And then I is going to be whatever it is right now plus 1, 5. At this point, Python says, is 5 less than or equal to 4? No. And then it breaks the loop, and it goes to print this statement, 4 factorial is, and then it grabs whatever the value of the factorial is. So here I'm using this F string print that notation that we learned about last lecture. So I encourage you to go through it yourself, just step by step. That's what Python Tutor is really, really useful for. Okay, so let's look at a different kind of loop called a for loop. Okay? And the for loop is going to allow us to rewrite that special kind of while loop that we saw where we initialize a variable, we test the variable, we do something to the variable within the code in a more efficient, more readable way. So in terms of
Okay, so I was just getting distracted by a thought, and I just wrote it on down on the paper so that after completing the lecture, I could get back to it. Now, since the thought is out of my mind because I've written it on my, the rough paper, and I'm just gonna focus.
special kind of while loop that we saw where we initialize a variable, we test
That's what I do when I get distracted by thoughts.
the variable, we do something to the variable within the code in a more efficient, more readable way. So in terms of our Netflix example, a for loop would be equivalent to something like Netflix, right? If you're not interacting with it, cuts you off after 4 episodes, right, to save bandwidth. And so there's a sequence of 4 episodes it knows it's going to go through if there's nothing, if you're not interacting with it. So if you've already gone through your sequence of 4 episodes you're allowed to watch without any interaction, it's done, right? It cuts you off. It says, are you still watching? But if there are still more episodes, if it only showed you 2 out of the 4, then it's going to keep showing you more episodes until it's shown you the 4. Okay. So this is the program we had with while loops a couple slides ago. And remember, we were initializing a variable, we were testing the variable, some condition here, and then we were incrementing the variable or doing something that gives us nice forward progress towards making this.
So the for loop is basically the shortcut with for loop for n in range. Okay.
Condition false. But it's really verbose. Certainly it works, and you can do it, but it's very easy to forget to do this, something like this, in which case you'll get an infinite loop. With a for loop, those 4 lines of code just look like this, these 2 lines of code.
So according to the lecturer, what they're trying to saying is that the n initially have when we use where's that? Where's my Gemini? So I got a doubt. When we use for loop, does the loop what is the initial value of loop variable? Like let's say for n in range, oh fudge, where is it? For n in range, let's say 5. In the Python, the initial values of how you use the initial, okay, by default the initial value for the n is actually 0. Okay, alright, so likewise the slicing function, it takes the start, stop and the step function. The range function can also take 3 arguments, start, stop and step, so arguments. Okay. Oh, so it's similar, it's somewhat similar to the slicing function. Okay.
So if there's a sequence of values you ever want to iterate over, that's what for loops.
I'm just gonna write it down.
Are useful for. So the syntax for a for loop looks a little bit different than a while loop. It starts with a for keyword. This is a variable that you get to name, whatever name you'd like. The keyword in tells Python, I'm going to make this variable take on values in this sequence. Okay. And again, we have a colon that tells Python we're going to start a code indentation here. And whatever lines of code you have that are indented are going to be executed however many sequence of values you have. So the first time through the loop, Python will make this variable name take on the first value in the sequence. And then it's going to execute this code. Automatically, Python will, after it finishes executing these codes, it will go back and set this variable have the next value in the sequence and execute the same lines of code. When it's done, it's going to make the variable here take on the next values in the sequence and execute those lines of code. And so these lines of code will effectively be executed however many values you have in your sequence. Okay. So more practically speaking, here we have a variable, so n in this case, in some sequence of values. In this case, I'm saying range 5. We're going to print the value of n. So I'm going to introduce range now. Range is a way for us to grab numerical sequence of values that have some sort of pattern. So if we just say range some number, the pattern is we start at 0 and we go up to, but not including that number.
Okay.
So range 5 means the sequence of values Python will iterate over are 0.
Right. So here's the thing. Let me just test this control for commenting out. So let's say x equals, copy this, for I in range we're gonna give till x plus 1, print what? Print I. So I will initially have the value 0. So it's gonna, okay, I, and I plus equals 1. No. So like here's the thing. If I'm gonna run this program, I'll get output. I'll get the output starting from the 0 to, let's say, 5. My x was 5, so I'll get output as from 0 to 5. But if I'll put this code over here, I'll get I starting from 1. Enter a number, so 6, let's say 20. Wait, yeah, wait, why do I have 21? Okay, enter a number, 5. Oh, I see where I did the mistake. I get it.
1, 2, 3, and 4. Range 10 means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So we go up to, but not including the value in the range, starting from 0. So each time through the loop, Python will change the value of n to be every one of those values automatically. So these two lines here for n in range 5 print n, the way they look like behind the scenes, and Python does this for you, is the first time it encounters the for loop, it sets n to be 0. That's the first value in my sequence. And then it prints the value of n, 0. Next time through the loop, Python will say, okay, I've done what you asked me to do inside the code loop, print n. I'm going to make n have the next value in my sequence. So it loses the binding from the 0 and makes it be 1. Okay, I've made n 1. Now what do you want me to do? Well, I'm going to execute whatever's in this.
Wait, so it means that I don't have to do this. Okay, alright. So the for loop automatically increases the value for whatever the loop variable is. And that's really interesting.
Indented, print
Whoa.
n. So I'm going to print
Whoa.
1. So I've already printed 0, then I've printed 1. I'm finished executing the code inside the loop, so now n is going to get the next value in the sequence. Lose the binding from 1, and you get 2. And so on and so on, and by the end, this program will have printed 0, 1, 2, 3, and 4. Every single value in my range. So it turns out that we can actually make range have 3 values inside the parentheses, not just 1.
Yeah.
1 is sort of shorthand notation if you ever want to start from 0 and want to go and go up to and including, up to but not including the value in the parentheses. But you can actually give it 3 values, a start, a stop, and a step. And Python will automatically generate a sequence of values that matches this pattern. So this should seem familiar to you, right? Because we've seen something like this when we were doing strings, right? Except that we weren't doing parentheses, we were doing square brackets, and we weren't doing commas, we were doing colons. But it's the exact same idea. Here we're generating numbers, actual integers that we want a loop variable to take on. So if we omit start and step, start by default is 0 and step by default is 1. If we omit step, by default it will be 1. So here, I in range 4, the variable I will take on the values 0, 1, 2, and 3. I in range 3, 5, I will take on the values 3 and 4. So we go up to, but not including the 5. Think about these 3 questions. So what are the range of values in the first one, and what are we going to print? So in 141, what range of values are we going to have I be? So I is going to be what?
What do these print? So starting from 1 to 3, yeah. For the second part, it starts from the 1, then it skips 2, then it moves to 3. So where's my so for the first program, it starts from the 1, it gives 1, then 2, then 3. In the next row, I'm just writing it to save some space. For the second, for j in the range, so it starts from the 1, It skips 2 because our step function is 2, and it gets to 3, and it then skips 4. Yeah, the, the 4 won't be included in this. Wait, j times 2. So 1 times 2 is 2, and 3 times 2 is 6. So we'll get this. That's the required solution for the second question. And for the third one, for me in the range, so that's an, what do you call it? String, yeah, string times me. So, oh, what? Step function is minus, starts from the 0. Okay, so it starts from the 0. Wait, if it's 0, then the me should be 0. So initially I should get a 0, and then $1, the dollar sign, and then you should get $2. Oh, I don't know why I did that. Okay, and then it's gonna execute three times. So 1, 2, 3. According to my logic, because initial the initial value is actually zero, so 0 times anything should be. Let me just test that. Wait, Python online. Okay, so let's say x equals 0 and y is equals to high. Print x times y. Wait, it gave me nothing. So does that mean I'm going to get null output? Okay, I'm not sure about this. So I'm not sure about this. Okay. Okay, let's just check
1,
the answers.
2,
2, 3,
3.
3. No, 4. No,
Yes,
4.
and we stopped. We go up to, but
Yeah.
not including the stop, which is a 4. And what are we printing?
I.
Yeah, 1, 2, 3. Just all. How about the next one? J. What will the values of J be? 1,
2.
3.
Oh, sorry, 3.
That's it. Yep, because we're
Yeah.
going every other value. And what are we printing here? Yeah, exactly. So we're doing an operation with each one of these J's. So we're going to print 2,
2,
and then 6. And how about the last one?
0.
We're stepping backward, right? The -1. So what's our start?
0.
4, and then
Wait, what?
3, 2.
Oh, is that so? So wait. Okay, wait. If that's the case, then we are gonna get. Wait, let me just move on to the. So we are gonna get dollar, 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 dollar. So the value for me would be initially 4, then 3, then 2, then 1, and we won't get any zeros, so it should be dollar, 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 then dollar 2 times, and then a single time dollar. So this is the pattern that we'll get.
2, 1, and that's it. We're going to down to, but not including the end, right? So we're not going to include the 0. And what are we printing here? Yes, $4 signs on one for the first time, and then $3 signs, and then $2 signs, and then $1 sign. Exactly.
So let me just write that how it works.
So the body obviously can do operations and can manipulate that loop variable. So each time that variable goes through, it changes, right? It changes, and then you can use that to your advantage. So here's another example of something useful. We can use for loops to keep track of how many times we're going through a loop.
My sum is a variable to store the running sum. So range then makes I be 0, then 1, then till 9. Okay, so my sum, so initially that variable has uh, the value for the variable is 0. For I in range, my sum equals print my sum. Okay, so if I'm not wrong, mathematically, um, it's basically, you're starting from, yes, initially the value for I would be 1, then 2, then 3, then 4, till so on, till 9. So that's a series mathematically. I'm just trying to relate this to the mathematics, because when you relate something to which is like mathematical intuition, it's easier to understand it. And my sum is my sum plus I. So this is for the value for I, and my ms, I'm just going to write my sum. Initially it would have value 1, then 2, then so on till 9. I guess it would be 9 if I'm not wrong. No, it won't be 9. I see where it's going. So the initial value would be 1, then it would become 1 plus 2, then it would become 1 plus 2 plus 3, till so on until 9 plus 8 plus, that comes. So in the end, when I'm gonna print my sum, that would have a value 1 plus 2 plus 3 plus till so on 9. And if it actually sees, that's an arithmetic progression, that's an AP. And we know that what's the sum of this AP, that's basically the sum of ms would be the total number of terms. So how many terms are there? Wait, 1 2, we have 9 terms by 2. So in case if you don't know, the formula is basically n by 2. The a1 plus an is basically the last term, which is 9. A1 is basically the first term, and n is the total number of terms, so it should be 9 by 2 times 1 plus 9, that's 10. So this should become 9 times 10 by 2, that's 45. So the ms should come out to be 45. Let's see if I'm wrong. I might be wrong. That's totally okay. I'm then gonna redo the question once more.
And in this particular case, we're writing a program that sums all the values from 0 all the way up to, but not including whatever is in
10.
Right, so how are we doing this? Let's do the memory diagram.
So it's basically the sum of n natural terms, mathematically, if I'll speak.
We've got my sum is equal to 0 as the first line. So this will be 0 in memory, right?
Yeah.
Bound to the name my sum. And then the for loop will generate for me the values 0 through 9, right, including. So I, the first time through the loop, will have a value of 0. So we're going to do the operations, or the code we're asked to do when I is 0. So my sum will be whatever it is right now, plus whatever I is, 0, so it stays 0. Python's done with the code inside, so now it's going to take I and change it to the next value in the sequence, 1. Okay? Now we're going to do again the stuff inside the loop with I being 1.
Wait. The initial value is 0. Okay.
So we're going to take my
Alright.
sum. Whatever it is right now and add 1 to it. So it's 1. And then we're done there. So Python will take I to be the next value in the sequence 2. And then we're going to do again, my sum is whatever it is now 1 plus whatever I is now 2. So it's 3. Again, I will increment to 3 automatically. Right? That's the next value in the sequence. So my sum will get a value of 6. And then I will change to 4, so on and so on and so on until I becomes 8. Right? That's sort of towards the end. When I is 8, the value of my sum is 36. Right? 0 plus 1 plus 2 all the way up to 8 is 36. And then when I becomes 9, Python will take my sum, whatever it is right now, 36, add 9 to it to give us 45.
So I was correct. Okay.
Okay, and then that's the end of the program, right? There's nothing else to do except to print my sum. So at the end of this loop, it's gone through 10 times, adding 0 all the way up to 9. We're going to print 45. Yeah.
So when I tried running it, it printed 45 at the top, and then it did like 0, 1, 2, 3, 4 under it.
Oh, maybe you have another print statement, or it might be part of another program that's being run beforehand that you didn't comment out.
Okay.
Yeah. Next question.
Could you use the plus equals syntax you need to explain one more?
The plus equals what it means? Oh, it just means it would be like
My
sum
equals
equals my sum
plus 1
plus
1 1
I.
Oh wait. Okay.
It's just shorthand notation because
Wait.
most of the your variable names might be really long, and it's really annoying to retype them. And so that's generally why that shorthand notation exists. Yeah. But it basically means take whatever my sum is and add I to it. And save it back into the variable my sum. Okay, let's have you try this code real quick. So here is code. It's already on the Python file to start out with. I want you to have this code. It's pretty close to working, but there's one issue. So we have this for loop that starts at start and ends at end, and we're keeping a running sum, and then we're printing the sum at the end. So very similar to what we just saw. But what I want this code to do is I want it to go and sum up the start and the end. So I want, if I have start.
You tried? I'm going to try this. Okay. Okay, fix the code to use the variable start and the end to get the total sum between. Okay, for example, start equals 3 and end equals sum should be at 5. So 3, 4, 5. So 3 plus 4 is 9. And 9 plus 3 is, that equals 12. Okay, so let's just start. Oh my bad. So start should be s equals integer. That should be input. Enter the starting number. Starting, and E stands for the ending number. Ending number over here for I in range, where we are starting from. So we are starting from S till e plus 1, then I'm gonna put the step function to be 1, even though if I leave the step function, according to the lecturer, it should be by default 1. And then what? Then what we are supposed to do? Okay, we have to define another sum equals 0. Sum equals sum plus what? I. Yeah, but wait, the initial value for I is 0. Wait, I just got this doubt. The initial value for n, okay. So it's basically, no, wait, I'm just doing it wrong. I'm actually doing it wrong. So we need to start with 3. So we need to start with 3. In order to start with 3, we need the value for I equals I plus 3. 3. What is 3 over here? So so 3 is basically, you know, um, the reference number from the slide. So that's basically S. Okay, that's the value. And sum, that's 0. Okay. Alright, now we get out of the loop. Wait, I got a doubt. I got a doubt again. In this case, what is the okay, so I will have value S. Okay, 3 3 3. Okay, so wait, let's just delete this. The sum will become 3 0 plus 3, you know, and then it gets out of the loop, and the value of for I is actually 4. So yeah, this should work. Print, what am I supposed to print? Print as sum. So let's just do this mathematically, where's my other pen? So let's say if I have to put, print some values from, let's say 10 to 15, we have 10, 11, 12, 13, and then 14, and then 15. So 1, 2, 3, 4, 5, 6. If I substitute the values into this formula, into this mathematical formula, the first term is basically 10 plus, and the last term is 15 times, how many terms are there? So we have 6 terms divided by 2, so that's 3. That's how many? 25 3 times 3 is basically 75. So if this is the initial value S, and this is the, what we gave, ending value, ending or the final value, this is the E, then the sum should come out to be 75 if our program is correct. So let's just run this program into the starting number. So our starting number is 10. Ooh, it's correct. Okay, I did it. Hell yeah. Oh, okay. All right. I'm just happy. I'm just happy over this thing that. Oh, fudge, man. Okay, let's just watch the lecture. Oh, At least I'm learning. I'm learning.
Start is
Man.
3 and end is 5. I want it to add 3 plus 4 plus 5.
Okay.
Right. And so this code is not doing quite that. And I would like you to fix it, or to tell me how to fix it. So it's down here on line 140-ish.
See, like, honestly speaking, did I did take a lot of time. If I would be a real student studying at MIT, I couldn't have done this in 4 or 5 minutes, definitely. Or maybe, I'm just saying, I'm not underestimating myself, but I am pretty smart.
First thing,
No. I'm actually the most, I'm just one of the dumbest person that you ever find me on the earth.
you should do is run it and maybe see what answer it actually gives you. So I just ran it. It gave me a 7. When you're encountering an output that's not quite what you expect, one of the first things to do, you can obviously use the Python tutor, but another thing you can do is put print statements at various places. Useful places would be inside the for loop. So here we can print I. Right? That's a reasonable thing to print out, and maybe we'll see exactly what values of I we are adding, because we know the summing works, right? We just wrote the program on the previous line, or previous slide. So we got 3, 4, 7, which is a little confusing. Let's make our print statement be a little bit better. I equals, comma, and then print the actual value of I. So what do you guys notice? I is 3, I is 4, and then it prints the sum 7. What's the problem
7.
with this code?
It's not printing out the 5.
Yeah.
We need to add.
Yeah, we're not adding 5, right? We're just adding 0 originally, plus 3 plus 4, and we've never added 5. So how can we fix that? Yeah. We can do n plus 1, exactly. So the range, remember, grabs the, plus 1. The range grabs these values, as numbers that it's working with. So start is okay, end is okay, but we go up to but not including end, right? So if we go to end plus 1, we're going to go up to but not including end plus 1. So if we run it now, it looks much better. So we've got I is 3, I is 4, I is 5, and the sum is 12. Perfect. So print statements, very useful when debugging code. Questions about this one, or does this make sense? Okay. The last slide I want to do before we do a summary is just to show you that factorial code we saw using a while loop a few slides back.
Okay, so that's the factorial loop. That's a code for the for loop to write. If you have to find any factorial for any given number. Factorial equals, okay, I get it.
So it looks really verbose, right? We kind of have to think about it for a while before we realize what it's actually doing. But it was, calculating the factorial. Obviously, good variable names helped us figure that out. That same code in a for loop looks like this, where the for loop looks like this. So we still have the initialization of x to 4. We still initialize our factorial, right, our running product to a 1. But we're losing those 4 lines of code that kind of make up that pattern of changing numbers with while loops into 2. So this line, I equals 1, this while loop with the conditional, and this incrementing of I become the for loop, and that's it. The for loop takes care of all of that, the initialization, the increment, and going up to but not including the last value, right, x plus 1. So we're going to multiply the factorial with 1, then 2, then 3, then 4, all the way up to and including x. Okay. So the big idea about for loops is they're going to repeat however long the sequence is, right? So you're able to repeat certain code a set number of times, which is really useful in some situations. While loops were useful in situations where you didn't know how many times you might want to repeat the code. So quick summary, we saw some looping mechanisms today. It was a lot of syntax.
That's a really great thing to notice that, the lecturer said that, there are some cases that we'll encounter where we don't know how many times we have to run the loop. In that case, we'll use while loop. Otherwise, just go with the for loop. So I'm just going to write it down because that's a very detailed thing to be noticed.
I know. But the finger exercises for today will certainly help. MITx also has extra help, extra exercises. It's really important to do them just to get the mental model for how exactly these loops work, right? And how they assign variables and how they do the checks behind the scenes, right? And it'll help you get faster at writing code and at doing quizzes as well. Okay. So that's it for today.
All right, let's just try the finger exercise 3. I'm just gonna zoom in. So assume you're given a positive integer value named n. Write a piece of code in the Python code that prints hello world on the separate lines. N times you can either use a while loop or a for loop. So let's just try it with, let's just try with both. We're gonna do it with both. Okay, so I'm just gonna comment this out. So x dot equals integer input, enter the number of times you want to print. Okay, so for I in range, starting from 1 till x plus 1, and the step function is 1. All right, I'm gonna print hello world. If I'm not wrong, this should work. 5 times. 1, 2, 3, 4, 5. Let's see if my code is correct or not. My solution, SOLUT, solution to the XER, that they gave the ROBLEN. Oh, what's wrong with my mouse? Okay, yeah. Is my SOLU solution correct? Anything that you would like to say? Pro level observations that will make your code cleaner and align with how Python is typically written. Range. Okay, So here's the mistake I did. The gem. Oh, so I completed 2 hours. Okay, wait. So the Gemini is basically telling me that if they have said that the input variable should be n, then I should name it to be n, and my mistake was that I named it to be x. So that's the one thing that I need to take care of. It if it would be, you know, a real test or something, then I would have just got failed. Okay, that's throw away variable. This tells you I need a loop to run many times when I actually care about the counter itself. Okay, so if I just write n plus 1, that would be sufficient. That's 10 times 1 to 3, 4, 5, 6, 7, 8, 9. Oh, wait, what? 1, 1, 2, 3, 8. That's not 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, what? Why it's 11 times? Wait, wait. I just did something wrong. So that's 5 times. So 1 comma. Now that's 4 times. Okay. So I have a doubt. I got a doubt when I'm using start comma stop. The output is less than 1, but if I'm just using stop, the output the output is normal. Why so? Gotcha. As in the arithmetic code, the region feels less than 1. Number of iterations is stop minus 1. Okay, the initial is 0. Alright. Okay. Alright, so I have to start with a 0. If I put the 0 over here, you know, and I'll put 5, I'll get 5 times hello world. Alright, so I guess that's all for today. And oh, oops, yep. So that's all for today. Done with the lecture 3, and tomorrow I'm gonna start with the lecture number 4. Today I might do another thing, linear algebra. So Notion, let me wait. Let me just open my Notion page. I have to study linear algebra, but I also have to study probability. So yeah, there it is. So probabilistic systems analysis and applied probability. I have to study this. I really need to get good in probability, and there. So the prerequisite is 18.02, which is multivariable calculus. I guess I've studied multivariable calculus, so I don't really have to study this. So the next thing, so today only, the next thing I'm gonna study is this probability. Um, Let me just zoom out. Lecture videos, probability model and actions, condition and Bayes rules, independence, counting, discrete random variables. It's gonna be hell of a show. How many lectures do we had? 25. So since since I'm not a student at MIT, and I'm currently not in any college, I could just just study one lecture every day, so it would probably take 25 days for me to complete this course. So I'm just going to start with probability just after closing this recording. And surprisingly, we have oh my god, 2 hour 11 minutes. So that's it for today's Python lecture 3. Goodbye.